Hello students. So today's topic is flowchart. Flowchart is the pictorial representation of the steps of the algorithm. For example, for solving a problem, we have created some steps of an algorithm. We will draw a flowchart. We will use a pictorial representation of those steps written in algorithm. So a flowchart is a pictorial representation of an algorithm. Programmers often use it as a program planning tool for visually organizing a sequence of steps necessary to solve a problem using a computer. So it is a pictorial representation of an algorithm. Whatever we have written in the algorithm, we will represent that algorithm in a flowchart. So programmers use it for visually organizing the sequence of the steps written in the algorithm. Programmers write actual instructions within these boxes using clear and concise statements. So programmers use these actual instructions in the boxes to using clear and concise statements. So directed solid lines connecting these boxes indicate flow of operation sequence in which to execute the instruction. So we use direct solid lines to connect these boxes, and the flow of the and these direct solid lines represent the flow of the flow chart. The process of drawing a flowchart for an algorithm is known as a flowchart. The process in which we draw a flowchart of an algorithm is called as a flowchart. So some basic symbols which we use in the flowchart are this oval. This is the start and for start and stop, start or start and end. Arrow. This is the direct. These are the arrow is the directed flow line. This parallelogram. This is the for input output. Rectangle is for processing, and this is used for decision making. For example, if condition is true, we will go this way, and if condition is false, we will go this way. So we will discuss these symbols in detail. The function of flowchart symbols: terminal, or we can say start and end. This is the terminal. This symbol is terminal, or we can say start and end. So terminal symbol indicate the beginning or start, the end, stop in a program logic flow. So this is terminal symbol is used in for start and stop. Next is input output. This is for parallelogram is for input output. Input output symbols indicate all program instructions to input output data from any type of input output device. So the input output symbol indicates that all program instructions to input output, whatever we have to input and whatever we have to output, we use this symbol. Next is processing. Rectangle is for processing. So a processing symbol represents arithmetics and data movement instructions. Hence, in a flowchart, processing symbol indicate all arithmetic process of adding, subtraction, multiplication, doing. So in processing symbol, all arithmetic calculation we can do in processing box. For example, we have to calculate the simple interest, principal into rate into time divided by 100. We do these types of formulas, uh, instructions in processing. They also indicate logical process of moving data from one memory location to another. Next is decision. A decision symbol indicates a decision point, which is a point at which a branch to one of two or more alternative paths is possible. So decision symbol. This is the decision symbol. So if condition is true, we can go this way, and false, we can go this way. Or if condition is true, we will go this way, and condition is false, we will go this way. So for example, we have as discussed a algorithm in our last topic. So we have calculated the profit and loss of a shopkeeper. So uh, if it is profit, then we will go some way, and if it is loss, then we will go other way. Next is flow lines. This is a flow line. So flow lines are arrow. Flow lines with arrowheads indicate flow of operation, which is the sequence of execution of instruction. Normal flow of a flow chart is from top to bottom, from left to right. So flow line is used to connect the different symbols of an algorithm. So normally a flow chart flows from top to bottom or from left to right. So benefits of a flowchart. What are the benefits? First is communication. Flowcharts are better way of communicating the logic of a system. So it is a better way of communicating because a pictorial representation of anything is easy to understand. Effective analysis. With the help of flowchart, problem can be analyzed in more effective way. So we can analyze the problem with the help of flowchart in a more effective way. Action coding. The flowchart act as a guide during the system analysis and program development phase. So during the program development phase, we can understand the problem easily in flowchart, and we can code the problem, and we can develop the software more efficiently. Proper debugging. The flowchart helps in debugging process, so it will help in finding the problems. If we have created a program and it has some uh, problems, we can easily debug, we can easily find the problem with the help of flowchart. Action program maintenance. The program maintenance. The maintenance of op- operation program becomes easy with the help of flowchart. It helps the programmer to put efforts more efficiently on specific part of the program. So in maintenance phase also, we can also flowchart can help us to uh, more efficiently maintain the program. So these are the benefits of the flowcharts. Next is limitations of flowchart. So flowcharts also have some limitations. What are the limitations? Complex logic. First is complex logic. Sometimes the program logic is quite complicated. In that case, flowchart becomes complex and clumsy. So for example, sometimes our problem is very complex. So drawing a flowchart for that problem is very tough. Alteration and modification. If alterations are required, the flowchart may require redrawing completely. So for example, we have created a flowchart and now our program logic changed, so we have applied another method for solving that problem, so we have to redraw uh, the flowchart. Then reproduction. As a flowchart symbol cannot be typed, reproduction of flowchart becomes a problem. So drawing a flowchart is very complex because we cannot type the symbols of the flowchart, we have to draw those symbols. The essentials of what is done can easily be lost in the technical detail of how it is done. So what is done, we are only concentrating on what is done, and the technical details can be lost in this in these details. So these are the limitations of flowchart. Some examples of flowchart. For example, we have to add two numbers. So this is start. So we have to input a, we have to input b, we have to calculate the sum a plus b, and we will print the sum and end. This is the flowchart for sum of two numbers. Another example, for example, we have to calculate the simple interest. Start, read, principal, rate, time. So we have to input principal, we have to input rate, we have to input time. Then we will calculate simple interest, that is principal into rate into time divided by 100. Then print simple interest and stop. So this is the flowchart of a problem for calculating the simple interest. Another example, for example, we have to find the profit and loss of an shopkeeper. So start, so read income, read cost. So we have to input income and cost. So if income is greater than equal to cost, if the selling price is more than cost price or equal to, then we will calculate the profit. If it is equal, then profit is zero. Calculate the profit, that's income minus cost. And if it is more, then we have some profit, we will print that profit either zero or more and end. And if selling price is less than cost price, then cost price minus selling price, cost minus income, then we have loss, and we will print that loss at end. This is how we can calculate a flowchart for income and loss. So all that's all I have today in flowchart.